Next up, Open Telemetry on Orbit by Clint Fredrickson.
All right, thanks everyone. First of all, is anyone here using Open Telemetry? Has anyone heard of Open Telemetry? Okay, a couple. Just trying to kind of baseline. We have a lot I want to cover a lot here, but I want to kind of understand where we're at. So I'll start off with just some wild claims, I think. I think in the space industry, you could really benefit from a modern high-level telemetry standard. And technology like Open Telemetry can kind of increase our development speed and decrease our integration time. So I'm Clint Fredrickson. I come from Cambrian Works and the principal software engineer there. I'm a relative newcomer to the space industry, so thank you all. Today I've learned a lot of kind of technology, terminology, those types of things. I have background in some SwRI imagery processing, applied cryptography, web services, those types of things. So just so you kind of understand where I'm coming from. I mean, you can find me at Clint Fred on GitHub, X, Hacker News, various places. Okay, so first, how am I going to define telemetry? So I'm going to say that telemetry is, data that we're collecting in real time. It could be metrics, things like temperatures, power, things from sensors. I'm also going to include some logging and traces into my definition of telemetry. This is really trying to get at this idea of observability. So we want to be able to infer the spacecraft's internal state from some kind of this set of external signals, but we want to, do it in the most precise way that we can. And I also want to say that, telemetry should be consumable by humans, maybe on the ground to make decisions, but also by systems on the spacecraft or other spacecraft nearby. So telemetry is, becoming more complex, and I'm kind of working in the small spacecraft industry, and we're seeing a lot of, satellites are getting bigger, more computers, lots of different operating systems, software stacks, hardware coming from different vendors. We're trying to integrate things together, and so kind of if everyone is doing their own telemetry stuff, integration time is kind of becoming just very large. And now we're seeing constellations of spacecraft come online. So not only do we have a spacecraft that may have dozens of compute devices or even low hundreds of numbers of compute devices, but now we're talking about, okay, maybe we might want to share telemetry with our neighbors to do some optimization. So open telemetry can kind of help us manage some of this complexity. Jesse Pulfer at Splunk has a really nice definition, and I'm just gonna, it's a little bit of word salad, so hang with me. But so he says, open telemetry is a vendor-agnostic observability framework that provides a unified approach to collecting, processing, and exporting telemetry data. So I just want to break that down a little bit because there's a lot going on there. So vendor-agnostic. So open telemetry is not driven by any particular vendor. There's no one like Splunk or Datadog or anyone that is kind of driving the roadmap there. There are multiple implementations of crucial pieces. So some of those are, a lot of those are open source, and we'll kind of look at some of those. Everything is standards-based. So even if someone is building a closed source implementation, it should be able to interoperate with open source ones. Here's our observability framework again. So, we're going to say that's metrics, logs, traces. So open telemetry is trying to handle all of those things. And then collecting, processing, and exporting. So we'll talk about each of those kind of more in turn, but one key concept that took me a long time to understand was that open telemetry isn't really talking about how telemetry is stored or how it's being accessed or exploited or, for analysis or anything like that. It's really about collecting the telemetry, kind of standardizing its format and pushing it out somewhere else. So open telemetry is open. You might, that's in the name. So, but it's part of the Cloud Native Computing Foundation. So this is foundation. It houses Kubernetes, Prometheus, about 70 other, open source projects. I would say it's relatively newer on the scene, or at least it's kind of newer in my view, based on, things like, or as opposed to like the Eclipse Foundation or Apache Foundation, those types of things. And it has really established a nice governance model where vendors are kind of involved, but they're not driving the roadmap, and you don't get these kind of standards and designs by committee as much. Now, I'm not actively involved with the CNCF, but just looking at from the outside, it seems like they're doing a good job. So for OpenTelemetry in particular, there are a lot of vendors that are participating very heavily because they can still bring their value in this kind of backend, telemetry backend. So again, OpenTelemetry is about getting the telemetry, but exploiting that telemetry is really left as an exercise for the reader or for the vendor in this case. And so the vendors really like this idea of kind of standardizing all of the collection and then being able to kind of sell their backends. Okay, so we're going to kind of go over some core concept of what OpenTelemetry is. And then after that, I'll talk a little bit about how we're using it at Cambrian in kind of one of our product lines. So we'll talk about some API specifications and SDKs, then the protocol for how the telemetry is transmitted, OpenTelemetry collector, and then we'll kind of tag on some back-end things as well. So let's take a look at kind of a high-level architecture of kind of what an OpenTelemetry system might look like. Okay, so maybe I'll use this one. Okay, so over here on the left-hand side of the diagram, that's your application, whatever your flight computer, your payload, whatever is emitting telemetry. So, we see the API and the SDK kind of sitting over here, generating and emitting the telemetry. And then it's flowing out to another process. So this is the OpenTelemetry collector. So the collector is not something that it's not a piece of or SDK that you're bringing in or a library you're bringing in. It is a process that you're installing and configuring for your application. And all of my kind of experience and examples here are based on kind of a Linux platform. And I'm honestly not sure kind of what other OSs and kind of environments that OpenTelemetry supports. But these blue boxes, these are kind of leveraging the open part of OpenTelemetry. And then over here we have, the back end that could be proprietary or it could be assembled from open source pieces like I'll show you here in a minute. So let's talk a little bit about kind of the API and SDKs first. So the OpenTelemetry project, the API that they have defined is an open standard. So, that ensures consistency across various languages or implementations. And they provide a kind of official set of SDKs that are out on GitHub. All your favorite languages here like Erlang or C, C++, and all that. So they probably have about 10, I would say, kind of official SDKs. There are third-party SDKs as well, and there might be, other ones that folks have implemented that aren't even open. So anyone should be able to kind of build an SDK as long as they adhere to the API. Okay, back to our kind of architecture diagram. We've kind of looked at the API and SDK piece. So now we're going to focus in just on the OTLP piece. So this is something that the SDK is emitting and is traveling kind of on the wire, let's say. So OTLP stands for the OpenTelemetry Protocol. And it's standard, it defines a standard format and protocol for the data to be transmitted. So SDKs in general output OTLP. And there's kind of two implementations kind of in the open already. One is built on top of HTTPS, and the other one is on gRPC. But they make, in their RFC, they talk about any request response kind of protocol should be able to support OTLP. Okay, back to our diagram again. So now we're going to focus in on the collector piece. And this is a really powerful kind of piece of the infrastructure here. So we'll spend a little bit of time. So first of all, again, it is an application. It's not something, not a library that you're integrating into your application. It is something, a service that you are installing. And it basically has three parts. It has the receivers, processors, and exporters. So this is, you can think about this as a pipeline. So you can define what receivers you want to kind of turn on. In this diagram, we're really focused on OTLP, but as we'll see in kind of our use case, we're activating other receivers as well. Processors kind of transform or filter or act upon the telemetry in some way. And then exporters are sending the telemetry out. So, you know, receivers, again, the OTLP is kind of the main one that we're focusing on in the diagram, but, you know, Prometheus, syslog, statsd, SNMP, like you can read from files, you can kind of configure all of that. Processors, I don't have as much experience with, but you can definitely use it to do simple transforms and filters. So if you say, hey, if this field in this telemetry packet that comes across, I want to filter, or I want to kind of blank that out. That's PII, or that's some kind of sensitive information that we don't want to actually be recording for some reason. That's easy to do. You can also attach new metadata fields. So, for example, you could attach maybe like a host name or a serial number of your unit or something like that to the telemetry as it kind of flows through the collector. And then exporters. So exporters you can think of as where do you want your telemetry to go next? And all of these you can activate multiple receivers and processors and exporters. But exporters are, you know, if you want to record your telemetry to a file, save it to a database, send it on to someone else to process, kind of that is all kind of fair game. Okay, so we'll shift gears a little bit. I've kind of blitzed through a lot of that, trying to give you a foundation for what OpenTelemetry is. But now I kind of want to talk about our use case and kind of talk through some of the things that we've encountered as we're integrating this. So we have a product called the Gig Router, and it's a NVIDIA Orin-based appliance. So it has a lot of network ports. It's basically meant to be either a edge compute device or kind of a space router or switch. So you can just think about it as a really capable computer that has a lot of network interfaces on it. And for us, telemetry kind of comes in a couple of different flavors. So the Gig Router uses power, and so we're monitoring that. We're monitoring voltage in and out, current in and out of our power system. We have a lot of different temperature sensors around the unit. We have a lot of network statistics, like you might imagine. Then we have, you know, this is I think it's a 12-core NVIDIA processor, and then GPU cores as well. So there are lots of things that just the SoC is actually just reporting to us through Linux. You know, CPU usage, different temperatures on different components. We also want to keep track. We have various network controllers on the device. We want to keep track of, you know, their stats, their temperatures as well. And we're running on Linux, so we want to also bring in syslog output, as well as any other applications that are running on the Gig Router. So some of those are Cambrian applications, some of those are customer payloads. So they might be outputting, you know, various logging. We want to collect that all as well. So some of our goals are we want to store all the telemetry as a base case, at least in some flat files on the system, so that, you know, you know, it's hard to lose, harder to lose flat files. So we might do things like slice those up by time, by subsystem, by level of severity. You know, some other filter we've implemented in the collector. We might want to kind of put telemetry out to those files. We want to provide a query interface, so something that's nice, so we can say, hey, give me all of the errors from this subsystem between these two times. So I don't have to bring all of the telemetry down to the ground or to another part of the system. I just need kind of get what I want. We want to be able to both let telemetry come out of the Gig Router to another system and allow telemetry to flow into the Gig Router if we want to centralize telemetry in that area. And we want to provide hooks for some anomaly detection and alerting for kind of special conditions. Okay, so I promised some kind of lessons learned or challenges here. So, flexibility and configuration is abounding in this kind of tool and this framework. But of course, that's all great until you try to go off the beaten path, and spoiler, like space is kind of off the beaten path for this system. And so it was difficult to kind of understand some how to use things in our use case. And we want to collect in flight, of course, and then exploit mostly on the ground. And that's not, we'll talk about a little bit more as we walk through some architecture, but that's not really the case for most OpenTelemetry deployments out there today. However, it is being used in kind of IoT use cases quite heavily. So that's more like what we're wanting. So those were helpful. And again, OpenTelemetry is not a kind of end-to-end telemetry solution. What you do for your back end and how you deploy that is really going to be what makes it, the telemetry, useful and exploitable. So if you want to see, oh, the temperature went on this one sensor, crossed some threshold, what were applications logging at that time, that's going to be provided by your back end. Okay, so a little high-level architecture diagram. So we'll start over here. So these are our local telemetry generators. So I'm not really saying what those are in specific, but there can be many of those, right? We talked about things before that we're measuring, power, temperatures, kind of system statistics, those types of things. And those are flowing out of those generators as OTEL. And I'm including syslog here because we actually are also wanting to do that, to capture things from the operating system. So the operating system, in this case, is a local telemetry generator. And everything inside of this kind of dashed box, this is kind of happening on the gig router, on that piece of hardware itself. So telemetry is flowing into the OTEL collector. This is that service that we've installed and configured. And we're enriching the telemetry, so we want to attach, what is the serial number of this unit in particular to every piece of telemetry that goes by, so that when we bring it into a system from where there's many gig routers dumping telemetry into one system, we can kind of look at the right stuff. Okay, so here's our base case. So we're using JSON files today. We've also looked at doing some kind of binary formats there as well if space becomes an issue. But we definitely want to collect all of this data just on the gig router, write it out to the file system so that we have it. Optionally, we can have things like a database. So here, this is a ClickHouse database. ClickHouse, if you're not familiar, is kind of a time series database, which fits in well with telemetry, of course. Has a SQL kind of query interface, so familiar if you're used to database types of things. And that's kind of a more structured way to kind of store the telemetry, kind of easier to exploit in that way. So, this is kind of the ClickHouse and JSON files. This is kind of our, like, in space, in flight backend. We'll attach kind of our onboard anomaly detection and alerting. So, if certain patterns are emerging, or we're seeing certain things cross certain thresholds, we might want to send signals out. That's going to be attached probably to a database, unless a customer is choosing not to deploy that. And then the query API, can sit on top of either a database or the flat files, and it'll do things like you would expect, let you kind of issue queries to get at the telemetry that you want. Okay, so this box on the right is supposed to represent other systems on the spacecraft. So, this could be other gig routers, either being used for computation or maybe for mirroring, or maybe to build kind of a virtual bigger switch or router. But we might want to send telemetry out of one gig router to another system, or vice versa. They might want to send us telemetry. Maybe we're doing both to kind of mirror, and so we have some redundancy across maybe many systems. Can really depend on configuration. There might also be processes on another system that they don't have, there's no collector there to kind of collect that telemetry, and they can connect directly to the OTel collector on the gig router and get their telemetry stored. And so this would be a good place to say, okay, if telemetry is coming from this remote place, we definitely don't want to tag it with the serial number of this gig router. Maybe it's being tagged in some other way. We know it's coming from some other source. Okay, so that's in flight. And I know this is the flight software workshop, but here's a ground, some ground software as well. You know, telemetry is really most useful probably when it gets to the ground. So, you know, maybe what you're doing as, you know, your use case is you're just going to collect those telemetry files on the gig router, JSON, protobuf, some other encoding, and you're just downlinking those, maybe all of it, or maybe you have some other way of determining what you want. You can bring those down and, you know, bring them into a collector, and then we've kind of built an open source, I would say, backend with a ClickHouse database, Grafana. A lot of you have probably used Grafana for building dashboards, or if you're doing more ops types of things. Maybe you want to, you know, generate reports or do something else. But, you know, on the ground is all of this is kind of like what we, kind of the backend that we provide, I guess. But again, you could go out and talk to one of 10 vendors and get a backend kind of more for your use case. And it should all just plug in because of standardization coming out of the collector. All right, and the last kind of use case I want to talk about is, you know, something we're working with right now in our lab and on our production line, is we're actually using this telemetry collection system as part of both R&D and kind of production, looking at different units. So here on the left, we have gig routers that are kind of under test. So maybe we have one just sitting on a bench somewhere. Maybe it's kind of undergoing some burn-in process or a stress test of some sort. Maybe a gig router unit has just been plugged into a test station, and we're testing out maybe the power subsystem or something like that. And we want to capture all of that telemetry. So again, we have our local telemetry generators and our collector running on that gig router. We're recording the data dutifully to the disk there, so we make sure that nothing is getting lost. But we're also, you know, these units are connected to our lab network or our production network. And, you know, we're shipping that all in real time over to our telemetry server. So, you know, every time a gig router is plugged in and it's running, you know, that telemetry is being collected. And, you know, when we ship an engineering unit to someone, we can give them all of the data. Like every time this gig router has been on, here's all the telemetry it has collected or produced, and we have collected. And on the production line, you know, we're using Grafana to kind of visualize some of that data. So yeah, we have test engineers kind of looking at this. We have you know, CEOs looking at dashboards. You know, how many gig routers are kind of plugged into the network. You know, customer could even look at this data. So yes, I did include. Yeah, so this is like just a snippet of, this is a dashboard for our temperature test station. So the tech that is kind of testing out these temperature sensors, so gig router gets plugged into the test station, you know, okay, now we're gonna spray it with, you know, 32 degrees air for a little while in this area. And they should see, yep, oh, there it goes up to 32 degrees. And this is, it's not like instantaneous real time, but you know, within a few seconds, they can kind of see that right on the dashboard on the production line. And then the same data is kind of being saved away as well. All right, so big picture, you know, it is possible to create a kind of a space-ready telemetry system based on open telemetry. We're working with a customer now. They're using OTel stuff for the rest of their spacecraft, and so we're kind of integrating into that. So that's been kind of an interesting experience. And really much of the heavy lifting is being done by components that, you know, we're configuring and installing. That OTel collector is doing a bunch of work. The SDKs are doing a bunch of work. stuff that we didn't have to kind of invent and figure out. And then we get to focus on building our core capabilities. Oh, and that's all. Thank you very much. Go ahead.
In your architecture, where does the telemetry decoding happen? And then is that able to handle both, say, streaming channelized data versus, say, a structured file type of data?
Where is the encoding happening?
Decoding.
Decoding. So the decoding is happening at the collector. So the collector understands based on what receivers you've turned on. So it can decode the telemetry coming out of any SDK, and then it makes it into its own structure. And then you can process it there. And when you send it out, you can say what encoding you want to use. So here I'm just saying, use JSON for the files and put it back into OTLP to send it back to another collector. So it's kind of configurable based on the destination.
We have a question online. How does OTLP compare to CCSDS? More overhead or less? I don't know. CCSDS is, I feel like kind of trying to attack the problem from a kind of a different angle, but I don't have any direct experience with it, so I couldn't say. I have another question online. How does this relate to Open SCADA, SCADA?
Not sure. Not sure what that one is.
Thank you. More questions?
No.
Thank you.
Thank you.